Good afternoon to those of us on the East Coast, and a good morning to those of us out west. Thank you all for joining today's edition of the Internet of Water Coalition's webinar series. For those of you who might not be familiar with our work and this content series, this bi-monthly webinar series is really a chance for Internet of Water partners, collaborators, to show off and demonstrate some of the great real life examples of the Internet of Water principles coming to life in different tools, dashboards, and real life projects. My name is Paula Basili, and I will be your host for today's session. So before we hand things over to our speakers, just a little bit of housekeeping. One note, yes, the webinar is being recorded and will be shared both on the Internet of Water's YouTube channel, as well as the Internet of Water's website. So if you want to be the first to know when that recording is live, if you want to share it, rewatch it, forward it to friends and colleagues, you'll be able to do so. The best way to know about to know when that's live is to follow the Internet of Water on LinkedIn as well as on our newsletter. So that's one. Two, we welcome questions. We know this is a really exciting project, and I'm sure folks will have questions about the road that it took to get here, as well as where things are headed. And so please use the Q&A function down below in the bottom of your footer menu to submit your questions. Questions are welcome at any time. We will ask our presenters to answer them towards the end of the presentation. So just know if we don't respond to them right away, that's because we are waiting till the end of the presentation for that more formal dedicated Q&A. And the last note is, if you are experiencing technical difficulties of any kind, please do note those in the chat. We will do our best to get everything fixed and set up for you so that everyone can enjoy the webinar. Okay. With that, I am excited to welcome our speakers for today's session. We are welcoming colleagues from both the Center for Geospatial Solutions as well as from the Arizona State University's Center for Hydrologic Innovations to help welcome and introduce a new platform, a collaboration that's been a while in the making, the Arizona Water Observatory. So thank you all again for joining us for the launch of this really special tool, and we're excited to hear more. With that, I'm going to hand it off to our first speaker, Kyle Anda.
Thanks, Paula. Um, Emily is pulling up our presentation deck. Um, good
Perfect. You can hear you,
afternoon.
see you. Looks great.
Awesome. All right. So, good afternoon, everyone, and welcome. Thanks for joining us for the launch of the Arizona Water Observatory, or AWO. I'm Kyle Anda. I'm the director of the data science and engineering at the Center for Geospatial Solutions, or CGS. We developed this in collaboration with Arizona State University to make Arizona water data easier to find, access, and use as part of the broader Internet of Water effort. So today we'll introduce the people behind the project, explain why it was created, and show you how it works. You'll also see some of the data sets available and a demonstration of it. We have 6 parts planned for the webinar, and then we'll have including some Q&A at the end, like Paula said. So next slide. So I do want to recognize the Center for Geospatial Solutions team. Our leadership team included Faith Sternlieb, our Associate Director for Innovation and Partnerships, who really took the lead on a lot of our stakeholder engagement and use case development. Justin Madron, Associate Director for Client Solutions Delivery, who took the lead on the initial sort of design process. Emily Wiggins, who's running this slide deck and handled a lot of project management. Amelia Green, who also handled a lot of project management. John Salmon, who built much of the front end you're going to see. Sam Ennett and Sarah Alonso Ficario, water data engineers and hydrology subject matter experts who, on our end, helped make sure everything made sense. And Colton Loftus, our software engineer on the back end. So And then just for some background context for anyone unfamiliar with CGS, we help organizations working on land, water, and social challenges use data and technology more effectively. Um, this mission is also closely connected to the Internet of Water, which, as you all know, is fragmented across many agencies and systems, and which makes it difficult for people to find and compare information. So our role in the Arizona Water Observatory was to help make those sources easier to discover and use through one consistent platform and pattern. Next slide. For those interested in the underlying technical stack, which is all open source, I'll just walk through that quickly. So at the top left, where it says Dashboard UI, that's essentially the application you're going to see demonstrated. It is connected to a backend, um, which is implemented, which is an OGC API server. So it serves open standard API patterns with this server called Paiju API, which is an international open source project that we are core contributors to. That backend both proxies data live from several federal and state sources, some of which are shown on here, but not all of them. So like SNOWTEL or the NOAA River Forecast Centers, um, and like Arizona Department of Water Resources wells. Um, and then that API will then serve through a consistent format all of this diverse data, um, which includes live proxied and some cached data in databases. So I'd like now to turn it over to Enrique Vivoni, Director of the Center for Hydrologic Innovations, to introduce the ASU team.
Good morning, everyone. Thank you for joining us. Especially thank you for the Center for Geospatial Solutions, who's leading the development efforts of the Arizona Water Observatory. My name is Enrique Vivoni. I'm a professor of hydrology at Arizona State University. Listed on this slide are the contributors to this effort from our university, and I like to call out software engineer Callahan Stormer, Senior Program Manager Vivian Hobbins, and user experience researcher Danielle Story, who really put in the work over almost 2 years to interact with the CGS team and a range of different water managers across the state of Arizona to create what you'll see launched today. Let me give you a little bit of background of what the Center for Hydrologic Innovations is. Our goal is to bring technologies into the hands of decision makers. Decision makers in the Western US and across the world are dealing with intense water challenges. Here in the state of Arizona, those span issues of groundwater permitting all the way up to the water rights of the Colorado River. So what we're going to visit today and demonstrate is the outcome of bringing technology into the hands of policymakers, planners, and decision makers. I hope that you take away a few lessons from the slides and the demonstration that you'll see today. One lesson is that there is infrastructure that exists and is open source and is available to all that helps bring together disparate data from different sources and creates a common vocabulary, organize it in a location. This location fetches the data in real time. This is the foundation for more ambitious efforts where one might bring models that are running live or satellite data that's being live streamed into that same place. We've spent a lot of time developing use cases that are relevant to Arizona water managers, including things like what's groundwater doing within the state of Arizona and how does it affect the particular groundwater basins? How do we track snow conditions within the state of Arizona? And how does it affect the stream flow that becomes water supply into our reservoir system? So the Arizona Water Observatory is more than a GIS tool. It's a framework in which we bring data together in a map-based platform that's online, that's open access, that's free, and that guides you through the selection of data sets in an intuitive user interface that then you can create your own process of selecting those data to answer a particular question that you might have in your agency or in your research center or at your university or at your private company, to be able to get to an outcome that helps you make a decision. And this is all based on open data standards. And this is important because we want to be building tools that can connect to other tools built by other states, Texas and New Mexico and California, so that at some point there's a coalition of these water data that help us together make better decisions. At least we want to monitor the state of our hydrologic conditions in real time in order to be able to assess where do we go and how do we make better choices. The tool, as you'll see today, is like a backbone upon which you can retrieve data, download it, and then take it to your preferred GIS or external software to continue your analysis. So I really hope that you engage with us and with the tool. We'll be providing some links to the tool itself here in a couple slides, and also some quick start blogs that help you begin the use of the tool. Thank you for everyone who's contributed to this at CGS, at ASU, and our partners across the water agencies in Arizona. And now I'll hand it back to Emily.
Thanks, Enrique. So I'll get into a little bit of some of the data sets that the AWO contains. We have 26 data sets included in the application. So as you can see here, they're from a variety of sources. I wanted to highlight in particular the ASU research products that we have, which include GRACE-derived Lower Colorado Basin groundwater storage level change, as well as data from the Arizona Department of Water Resources, including their groundwater site inventory, management basins, irrigation districts, and more. We are very excited to show in the demo and in a couple slides what these data sets are going to look like for users. So here's an example of the user interface with some USGS PRISM mean monthly precipitation data displayed. As you can see, the darker blue cells indicate a higher average monthly precipitation for June 2024, and the lighter colors indicate less. Here's another data set displayed. So this is that GRACE data I was talking about, and you can see a little more in John's demo, but it's all intuitive to click around in and explore. One of my favorite parts of the AWO is the integration with elevation data. So as you can see here with snow water equivalent from NOAA, as well as the USGS's 3D elevation, you can get a really good sense of how water levels can be impacted at different elevations from rain events, snow events, and things like that. And then finally, again, John will be highlighting this. We have the newest function of the AWO, which is the compare tool, where you can see different data sets across time displayed like we have here. So I hope this gives you just a little bit of a taste of some of the data and things you can do with the AWO. And now I will pass it to John, who will be talking a little more in depth about the technical components and then doing a demo.
Hey everybody, my name is John Salmon. I am a front-end software engineer here at the Center for Geospatial Solutions. I'm going to be taking you through the back-end overview of the AWO platform, and then we'll jump into a very brief demo. So the AWO platform is built using OGC API standards. These are standards that allow the user interface to function with any dataset that adheres to these standards. What this means is that any time a new dataset is added to the API or an existing dataset is modified, these datasets are automatically accommodated and supported in all the tools available on the platform. Now, these OGC API standards are open source standards that, one, improve and standardize metadata, allowing APIs to clearly describe the data they contain and the methods for interacting with them. They also output a number of widely accepted formats, including HTML, JSON, JSON LD, coverage JSON, GeoJSON, and more. These APIs provide a singular access pattern, which means that there's no need to write idiosyncratic API calls related to just one data source, or no need to rewrite data analysis scripts. Simply write it once and you can point it at a variety of sources. And these are standards that come in a variety of flavors, including environmental data retrieval, which is the primary standard leveraged by the AWO, but they can also relate to things like moving features or even the Internet of Things. And since we are using that same OGC API backend with a singular access pattern, what this means is that this backend is reusable across multiple user interfaces as well as for multiple analytical purposes. So on the left-hand side, we can see an Esri ArcGIS dashboard. That same data set is able to be visualized in the AWO UI, which you can see just underneath it. And you can even throw it into an open source data explorer like QGIS. And again, reiterating that singular access pattern, right on the screen here, we have two different data sets. On the left-hand side, we have access to water coming from the Army Corps of Engineers. And then from ADWR, we have the groundwater site inventory. We can see the path to each of these data requests. So we're interacting with the items edge on both of these. When we look at the locations edge later on in the demo, we'll see that it's the same API pattern and the same query variables to interact with these data sets. The only thing that is going to differ is the data points that they contain. So for the next couple of slides, we are going to be following along with kind of the process to retrieve data as it exists currently and how the AWO addresses that particular issue. We'll be using the use case that you can see on the left-hand side, where a water scientist wants to understand recent surface water and groundwater trends in the Tubac area and evaluate them in the context of land cover and historical hydrometeorological model outputs for a water use planning study. They'll need the following parameters over a specific time interval. So what do we need to do? We are going to find source data. We're going to identify the parameters that we're interested in, select a time interval, and export that data. What does this look like in today's landscape? This means that you're going to be going to a number of sites, navigating sublinks, using menus and all kinds of filter options, and ultimately getting a static output file that comes in a variety of formats. This slide doesn't even contain the final step, which is the transformation of all of these different data sets into the format that you need. And since they are static, every time that you need an updated set of data, you'll need to repeat this process, navigate all those sublinks, and get that static data output. With the AWO, we greatly simplify that process. There's no need to go to multiple sites or learn multiple different menus to interact with the data. Simply draw an area of interest, explore the data sets, add instances of those data sets as layers, explore the parameters contained within, select parameters and identify a time slice, do a little bit of visual confirmation of the data, and take that data out of the system. I've described the AWO as kind of like a data grocery store, where you can come in and see the aisles that you are interested in, go down those aisles to explore all of the different ingredients or parameters, sample those parameters. We're kind of like a super Costco. We let you sample everything. And once you've identified the particular parameters or ingredients that you're interested in, you can take those home and cook with them. And similar to a grocery store, once you know the ingredients that you need and you just need to get a refresh or a re-up, you can use the links to submit a request to the API and get that updated data. It's kind of like a grocery delivery service that you can get from your local grocery store. All right, so with that, I'm going to go ahead and take over the screen and walk you through a very brief demo of the compare tool functionality. Alrighty, so now that we are in the AWO, as I said, this is going to be a very brief demonstration. I can't necessarily cover all of the functionality within this demo. So if you do need some help as you navigate the AWO in your own time, please do use the help modal. If you need to access it again, use this info button in the top bar. That'll show the about modal where you can find the glossary that contains a number of definitions for key terms used throughout the application. If you have a question that may be answered in the FAQ, If it isn't, please do submit a GitHub issue or send an email to us that you can find both links to both of those resources within the Contact Us tab. And then we have the user guide on this page that covers all of the functionality within the AWO in great detail, with diagrams and clear guides to all of the features. It is comprehensive and 94 pages, so I highly do recommend checking it out. And like I said, we have this Contact Us tab right here that will allow you to access the repository containing both the backend and the front end code for the AWO. We have a link to the preferred email address for the Center for Hydrologic Innovation, so you can get in touch with us. And then you can also use this link right here to jump to the landing page for the Center for Geospatial Solutions. And I'm going to move very quickly through this next portion right here and just talk about some of the general landscape of the application. On the top bar, we have a number of tools, including the share tool, which can be used to share all of the data sets and layers that you have selected, as well as the current view of the map and any styles that you have applied. So it allows you to share all of your selections with your colleagues rapidly so they don't need to retrace your steps to get to particular points of interest. We'll be talking about the export tool at the end of this demonstration and the compare tool just a little bit later. We also have a legend tool up here, which will show all of the layers that you have added onto the map. As we don't have any layers yet, we don't have access to the legend tool. And then this one right here will allow you to change your data boundary. The data boundary is what you can see in the dark blue line surrounding the state of Arizona. That is the bounding box that is used for all of the data requests. You can also update that to include a wider geographic area around the Colorado River Basin. And you can use this checkbox right here to apply strict, which means that all of the features outside of the particular feature of interest, so outside of that Arizona state boundary, are going to be filtered from your results. The draw tool, which we will use later on in this demonstration, is how you specify an area of interest. It also contains a measure feature, which you can use to get a quick check of distances based on miles, feet, or kilometers. The screenshot tool allows you to download the current view of the screen at a specific dimension, so your PNG will match the dimension that you specify. And then this last tool right here allows you to change the base maps and toggle off the 3D terrain, which is shown by default on all desktop computers. And then this geocoder right here allows you to look for any address within your data boundary area, so within the state of Arizona or the Colorado River Basin. And on the map right here, we have just a Mapbox GLJS instance, again with that data boundary, which you can see in the dark blue. And then we have the left-hand panel where we'll be doing most of the work for this demonstration. What we show in this first tab right here is just the data sets. Once we have layers, we can access the layers tab down below. If you scroll down the data sets, you can see all of the data sets contained within the AWO. If you expand any of these data sets, you can see a description of this data set. You can choose to select a default parameter, which means that any layer, which you can create using this button just to the right of the title of the data set, this means that any layer will have that parameter selected by default. And then lastly, you can use these links to access the landing page for this data set in our API. You can use this link to go to the original source of the data. And then this link right here will take you to the methodology used to produce the original source data. All right, so with that, we are going to be sort of tracing along with one of Sarah's blog posts. For our particular use case, we are going to be pretending that we are an analyst interested in snow water equivalent data, as well as river flow data from 2018 to 2022 for the Snowslide Canyon area. So to do that, we are going to first use this filter functionality right here using the text input that allows us to search across dataset names, as well as parameters, and the units associated with those parameters. And we can use this feature right here to narrow data sets by the original provider and narrow down our data sets based on the categorization of the data that they contain. For this demo, we're going to keep things pretty simple and we'll just use this text input and look for snow water equivalent. Now, we have a number of hits, which means that these data sets likely contain a parameter relevant to this particular text string, which we can complete out as to snow water equivalent. For our particular use case, I'm pretty familiar with the SNOWTEL dataset. So I'm going to go ahead and add an instance of that dataset as a layer, which now you can see renders the location data on the map. I'll go ahead and jump over to the Layers tab, which you can see is now active with a count of the number of layers within the system, and start to do a little bit of curation work to work towards the data that I ultimately want. So now that I'm in the settings tab, I'm going to choose to rename this layer just so that I can track it a little bit easier throughout the application. And I'll specify that date range, which again is just 2018 up through the end of January 2022. Important thing to note is that if a date input is under this settings tab right here, this means that it does not influence your data retrieval. It simply influences the visualizations, time series, and tabular data that we show throughout the application, but won't affect the data that you get into the AWO platform. Anything that affects your data request or the request for points or any other geographic information is all going to be contained within the data tab. We'll see another data set later on in this demonstration that does have date inputs under the data tab. Therefore, those data inputs will affect the data retrieval. So like I said, we are looking for snow water equivalence data. So I'm going to go ahead and type in snow water equivalent, and I'll just take the basic parameter option. When I hit save, what it's going to do is request all locations that have at least one measurement for that parameter. If you select more than one parameter, then you will get all the locations that have at least one measurement for at least one of those parameters. So sometimes narrowing things down to just one parameter will get you to your desired results a little bit faster. When I hit save, we will notice that all of the points will not disappear, or we will have all of the same points on the map as we have presently. That is because all of these SNOTEL locations do have at least one measurement for snow water equivalence. And now that I have specified a parameter and a date range, this means that I can produce a visualization of this data, which you can see quickly by double-clicking on any of the points, and that'll render a pop-up with the visualization of snow water equivalence over the time range that we specified. If I have more than one parameter, I can toggle between those visualizations using this dropdown, and then I can explore all of the properties on this location through the Properties tab right here. That allows me to see all of the specific data points associated with this geographic location, including things like the HUC region or the name of the station. Now I'm looking for a particular location and data related to a particular location, so I'm going to use a couple of tools to get to that result a little bit quicker. The first one we're going to take a look at is the label feature, which allows labeling all of these locations by a specific property on that feature. So I'm going to go ahead and select name. And now that I have selected name, anytime we refer to a location from this layer, we'll refer to it using the name property. Now I'll still have to hover over all of these points. Maybe I don't know exactly where Snowslide Canyon is on the map. So this isn't going to get me to my result very quickly. So to do that, I'm going to use the search functionality over here. And if I start to type in, you'll notice that points did disappear from the map. And what we get in the left-hand panel is all of the matches that we had on that text string. So just matching 1, 2 onto station triplet, timestamps, and more. But we are looking for things related to Snowslide Canyon. So if I start to type in snow, we'll quickly get to a singular result, which matches Snowslide Canyon. Perfect. Now, if I use these buttons right here, that'll either select the location, placing it into a curated list. That'll help me keep track of a particular location throughout the application and all of the tools that we have. I'll go ahead and do that now. You'll notice that that location is now the highlight is translated from black to white. That'll indicate that it is in my selected locations list. So if I clear out my text input, we can see all the other locations are surrounded by a black outline. Our selected locations are in white. So now I have my particular location identified. I happen to know that I'm going to want to interact with the National Water Model datasets. Those datasets tend to be rather large, so it'll be helpful to specify an area of interest, which will help me narrow down the results and reduce some of the visual noise. So in order to do that and produce that area of interest, I'm going to use that draw tool that we mentioned earlier and just draw a simple shape around my point. Now, when I hit apply, that'll reduce all of the other points that are outside of my area of interest. So I'm only getting data relevant to this specific geographic area. And now that I have my area of interest identified, I'm going to start looking for that river flow data. So to do that, I'll type in river flow, and I'll get a match from the National Water Model Channel Routing Output dataset. I'll go ahead and add an instance of this dataset as a layer, and I'll get this warning right here. So the first requirement for this data set, as it is rather large, and we want to make sure that your browser experience remains optimal while working with coverage JSON data, we have a couple of restrictions that are just specific to in the application. If you want to interact with this data set in full, that can be done using the API. But to look at these restrictions as we have them in the app, we need to make sure that we have an area of interest or a polygon that's roughly 1/8 the size of Arizona. Already done. We need to make sure that we have a date range that is no greater than 1 day. We need to make sure that we only have one parameter selected and at least one parameter selected. If we don't want to see this warning again, we can hit this Don't Show Again button, and that'll turn that warning off just for this data set. If other data sets have warnings, they'll continue to show those to you. We'll jump over the Settings tab, but important to note, the date inputs have moved from the Settings tab to the Data tab, so these will ultimately affect our data request. So I'm just going to make sure that I request data somewhat close to my period of interest so that I can be confident that I'll have measurements close to that period of interest. Now that I have that date range specified, I'll go ahead and select river flow from the list. We'll jump over the dynamic visualization that you saw in Emily's portion of this presentation and just get to the compare tool and the data aspect of this presentation. So now we have the National Water Model channel routing output added to the map. Since I'm looking at river flow data related to snow water equivalents, it likely makes sense that I'm wanting to look at some of the data points that are downhill from my area of interest or my selected location from that SNOWTEL data set. So I'm going to go ahead and change my map view so that I get a little bit of that 3D terrain, and that'll allow me to see some of the points that are downhill from my selected SNOWTEL station. So I'll just grab this point right here, and we're going to jump now into the compare tool. So the compare tool allows us to compare two different data sets and two different parameters over a unified time interval. So all the visualizations we produce will match the date inputs that you can see here in the top bar. If there are any gaps in the data for any of these data sets, those gaps will be clearly shown with the same x-axis. That'll remain the same no matter what. So I'm going to go ahead and select my snowslide canyon location. You'll notice that I have two different groupings right here, one being the selected locations and one being the other locations. Since I didn't select Fort Valley, it's in the other, did select snowslide. So I'll go ahead and add snowslide location as a visualization on the screen. Now I can view this visualized coverage JSON data in both chart and table format. If I want to reduce some of the visual noise, I can use this toggle right here to turn off all the extra buttons, just reducing some of the visual landscape that's occupied by some of the functionality. I'll turn that back on and turn off the table. I can also use this data window to narrow down the amount of data that I'm looking at and sort of move along the totality of the data just with that narrowed window. I'll go ahead and restore that, and then we're going to add an instance of the National Water Model, just that same selected data point that we selected that was downhill from the SNOWTEL station. We're going to jump back to the map and see if we can get better data from this point right here. Now we may have overwhelmed the National Water Model Channel Routing Output API. So with that, I'm just going to talk through some of the other features that we have in the app or within the compare tool specifically. If you use this button right here, that will take you to full screen for just the compare tool. That'll allow you to see everything in a standardized view. And with that, we're going to jump over to the export functionality. And you can see some of the API touch points that we have throughout the application. This will allow you to interact with the AWO via the API and provides clear requests that we use to perform all of the actions within the platform. So this first request right here is the request that fetches all of the GeoJSON related to that snow water equivalent parameter. So you can see it's specified using the parameter name query variable. If you throw that into your browser, you'll get the feature collection of all of the points related to that parameter. And now if I select a location from the left-hand side, I'll get a visualization of that particular location, as well as an individual card for that location. Now this request that you see right here differs from the one up above. This request right here is just specific to that location. So you can see we are looking at station 927, getting our snow water equivalence data over the date time that we have specified. I can render the same chart that we've seen a few times using this chart button below, I can also get the raw GeoJSON of this particular feature and copy that out using this button right here. I can view all of those same GeoJSON properties in a tabular format if that's my preference. And then this button right here will download a time series version of the visualized time series. If I have more than one collection selected, I can download all of the CSVs to get all the time series for all of my locations using this download all button. And I can also download all of the location data, so that feature collection in both KML and shapefile format. Again, I do encourage you to explore the AWO in your own time. Please do consult the user guide. And with that, I'm going to go ahead and hand it off to my colleague, Emily, to talk you through resources and documentation.
Thanks so much, John. That was great. I want to highlight that one of my favorite things about the AWO is that 3D capability. I think that's really cool. So appreciate you showing us that live. So to close with some resources and documentation, a few things I wanted to highlight. Like John described in the demo, the user guide is accessible through the AWO website. It's got over 100 pages including a lot of detailed documentation about the different data sets and some more example analyses and workflows that you can work through. So we really set it up for users to run with it for whatever your purposes and needs may be. So we encourage you to check that out. I also want to give a big thanks to the AWO technical work groups that contributed to this project. So the folks who were a member of the technical work groups were directly responsible for including the factors in the AWO that we ended up with, including the compare tool and the different data sets. So for the folks from these organizations who contributed, thank you so much. And we also held 2 stakeholder engagement workshops, and there is a report available if you're interested in seeing that from one of them. And that includes a lot of information about kind of why we arrived at the AWO that you see today. So encourage you to check that out if you're really interested. And again, grateful to the work group who contributed a lot as well. Again, in terms of our documentation, want to highlight the GitHub in case folks have questions about that sort of technical side of things. There's a lot of great documentation on the GitHub page. And then finally, John also mentioned the Quick Start blogs. So we put together 3 Quick Start blogs that will be linked in the chat, as well as the rest of the resources. And what our vision for these was there's one that's an entry level. So we covered kind of a beginner to the AWO, kind of just getting you set up with some of the processes that John went through today, adding data, working with the data, changing colors, things like that. And that's an entry level one that's good for anyone kind of just getting their feet wet with the AWO. And then there's also 2 more that are available through GitHub. And they actually include videos as well as written documentation and code-based documentation for how you can kind of take the AWO and work further. So there is a groundwater quick start blog and a surface water quick start blog. So after this webinar, we hope this will not be the end of your engagement with the AWO. Encourage you to check out any of those resources and documentation further. With that, would love to get into the Q&A. So I will turn it back over to my colleague, Paula.
Thank you so much, everybody, for walking us through such a robust platform. A reminder for everybody, if you do have any questions, either about how the tool was developed, where it's headed to from here, feel free to drop them in the Q&A function below. And in the meanwhile, we have some questions of our own. And Enrique, one of those is, I'd love if you could just reiterate for folks, what was that original vision for the AWO? Like, how did you create that vision? How long has it been in making? And I'm curious, the team described a long 2-year process to really bring this tool to life. Was there any point at which in that 2 years the vision evolved at all as you actually got into the nitty-gritty of building out a resource like this?
It's a great question, and I think it's a question that will resonate with many of our webinar participants. We live in a world where we have too much data, and that world is those of us in the technical realm struggle with bringing that data together in one place. John mentioned this very nicely. He gave us an example of the business as usual case. And this happens in the practitioner community, it happens in agencies, it happens at universities. A lot of the time that we spend before we're answering the question that's posed to us is in assembling the data in one common format, in one common location, in one geographic projection, with one standard set of units in the spatial location of interest. What we're trying to do is short circuit that painful process so that you get to answering the question posed to you, whether it's by a client or it's by the director of the agency or it's by the legislature, be able to answer that question more quickly. Think of this as a place where the data is being brought together, where then you can start using your creativity to answer the question. So that was the original vision. And of course, it's evolved because our technical stakeholders we've engaged with on a monthly basis for more than a year, it really helped narrow down how the user experience needed to be for the demo that you saw today. Narrowing down what are the essential data sets for this first release. You saw there was about 26 data sets. That's not the entire universe of possible water data in Arizona. We're trying to give sort of the blueprint that other agencies can say, well, what if my data were there? I can then link it to the snow data, or I can link it to the river flow data, or I can link it to the groundwater data. So this is an open call and encouragement for others that host data to simply reach out to us so that we can bring this data in through your API into this platform. What kind of user communities could potentially use this? Gosh, there's a lot of possible uses. If you are at Salt River Project, for instance, and your job has to do with reservoir operations of the 7 reservoirs in the Salton Verde system, knowing the amount of snow that happens across these snowtail sites, knowing the river flow that's coming afterwards and forecasts of those river flows, those are essential pieces of information for you to make decisions about whether you store water in a reservoir or it's released. And similarly, you could be in a groundwater agency like ADWR, and you want to know what are the regional conditions of groundwater as viewed from space, and how does that map to the groundwater basin of interest. We have a tool here, a data set called GRACE, satellite observation, that you can overlay with the ADWR groundwater well data to get to the decision-making process much more quickly. So I think we've come a long way in making this vision a reality, and kudos to the team, Colton and John and Kyle, who've brought these ideas together and made it the reality that you saw today.
Thank you, Enrique. It's really exciting to hear that kind of ambition, right? For a very wide group of users, and really create that like single source of truth, really, that everybody can rely on. So it's great to hear that. I'm going to turn things over because I think you spoke to a few of the underpinnings that of the Internet of Water vision, right? Interoperability being a big one. This question is for Kyle Onda. I'm wondering, can you talk a little bit about how the Internet of Water vision really shaped the development of the AWO and what you may have learned as someone who has been a part of the IOW journey for so long, in this particular project about really putting those open water data sharing principles into practice, that you might bring forward into other projects as well.
Yeah, so a lot of what we did here in this project was implement tooling that makes it possible to fairly easily, I'm not going to say it's not effortful, but fairly easily for a data scientist or developer type to transform data live that's coming from a source government agency system um, into a common format so that downstream data users don't have to, you know, worry about discovering the source or worrying about transforming multiple sources into one thing. So that's been, for a long time, the Internet of Water was about trying to get everyone to adopt the same data standard, um, which we still ideally would like to do, right? Would like folks to do. But this this effort represents a big kind of step forward for us in meeting at least IT folks halfway in doing that, right? Because this open source software offers them a very consistent and well documented framework to implement those transformations. Um, the I would say that's probably the biggest step forward here. The other thing we did as part of this project was we generated a lot of very specific use cases that weren't all addressed by the state of the part that you have here, but we engaged a lot of water professionals in Arizona um, that we have a lot of that have been published earlier in this process in the Arizona Water Observatory workshop reports. Um, that you know we think the broader Internet of Water community can keep in mind as they build out data infrastructure and data interfaces wherever they may be.
Very cool. Were there any use cases in particular that surprised you or that weren't on your radar?
Mm, there were a few folks who wanted integration with pretty fine-grained land information um, to look at things like land use efficiency, and that's and that's tied up with some things we've known about in the past but haven't engaged with directly, like ET for consumptive water use at the farm level, right? But this had more of a, but people were more interested in kind of almost an urban focus, um, which was interesting to me. That was one of mine. But that I'm biased because my background's in urban planning, so it jumped out to me seeing that finally in this sphere.
Yeah. Very cool. Okay. Big thank you also to Carrie Hurdle in the chat who dropped in a few comments. Two specific or questions, I should say. Two specifically, how is the AWO ensuring quality and accurate data? Enrique, I know you mentioned the APIs that kind of are a big part of this project, but I'm wondering if maybe you could speak to that or anyone else on the team. And secondly, too, are you all thinking about possible integration of more private or protected data, for example, water source points in the future? That seems like it could be a challenge to tackle. How are you all thinking about that? Or are there any other ways that you're hoping to grow the AWO from here?
Hi, Carrie. Good to see you. The um, we worked together before. The okay. So the question on I need to go look at them. So private protected data. I mean, we have several approaches in our back pocket to do that that weren't part of this specific project, right? But there's authentication layers we can put on the API um, to restrict access at the data set level to certain individuals. Again, this platform is completely open. The other sort of category of thing, particularly when you're talking about water source points, is to sort of provide them at an acceptable level of aggregation. So, for example, representing them as the Huck 12 unit that they are in, um, or some circle that they are in. Um, and so we're slowly building up the tooling to automate more of that process. But ultimately, whether that's acceptable has to do with the steward of that data that needs to be kept private or protected. Um, the ensuring quality, accurate data. For the most part in this project, we're just relying on only taking from vetted public agency sources, and we always link to the documentation of those sources so people know what they're getting. We also, in the case of like provisional data, we do basically just try to keep that data updated to the same state that the agency is publishing it in. That sort of by default happens via the API proxy, and in the rare case where we're caching data, um, yeah, basically that involves building in an update cycle, which is also automated in any case. But the short answer is no. This project is not doing direct QA/QC on like stream gauge data. That's not the role of this platform, at least for now.
Great, thank you, Kyle. And thank you to Eleonora De Maria, who also submitted a question, this time about kind of long-term availability and maintenance of the tool. So what does maintenance for a tool like this look like? What does it take to keep a tool like this updated? And where do you hope to see it go from here?
Well, let me take the first stab at this. Part of the underlying design is to have this tool be as maintenance-free as possible. In a sense, you're retrieving data from existing sources. We do assume those sources exist in the future, and they are not somehow offline. So that's outside of the control of this particular platform. It's hosted at ASU at the moment. We continue to expect to be hosted at ASU for the foreseeable future. And we're looking to expand our efforts, our capabilities through new projects. A little bit of that you saw in the demo with the Colorado River Basin area of interest. We'd like to bring together more data across the river basin from other states to have this platform be a trusted location for Colorado River Basin discovery of data and eventual discussions about the renegotiation of the Colorado River Compact. As we all know, this is an important discussion happening here in the West. So making the data discoverable and trusted is part of the goal here, and we hope to expand this effort in the future. Thanks for the question.
Thank you, Enrique.
I can
Yeah.
jump in on the maintenance aspect of that. So like Enrique said, this platform is built to stand for a long time. Everyone who was on the development team heard me mention opinions and staying unopinionated. This means that the only thing that needs to change is the data that we are showing, and the platform itself will just stay up and stay fully available and reflect all of those changes as those data sets get added. But this project is open source, so if you do run into issues or features or anything that you want to contribute to this project, you can access that repository link and either open up a issue or submit a pull request to request a new feature or functionality.
Nice, thank you. Perfect. Okay. Well, it seems like that's it for our questions today. Thank you again so much for everybody who tuned in and took some time out of their schedules to join us for the unveiling of this really exciting new tool. And also a big thank you to all of our speakers today for prepping this great introduction. For anybody whose first time it might be joining our webinar series, hosted by Internet of Water, and they're really meant to be a spotlight on really exciting water data discovery and sharing projects happening right here in the real world. And so if you are interested in more content like this and seeing more great tools being created out in the world, definitely sign up for our mailing list. Stay up to date on all updates relevant to the IOW, including, of course, the webinar recording, and stay in touch. Thank you all.